Back in 1798, Thomas Malthus warned that population would outrun the food supply. For 200 years, farmers kept proving him wrong by growing more. But a new generation of thinkers said Malthus was not wrong. He was just thinking too small. Neo-Malthusian theory keeps the same core warning that growth can outrun supply, but it widens the danger from food alone to water, energy, land, climate, and biodiversity all at once. The AP-ready definition is that population growth, combined with rising per-person consumption, can push past Earth's carrying capacity across multiple systems, producing scarcity, conflict, or ecological decline unless policy slows the pressure. The exam shortcut is simple. If a question mentions water scarcity, climate stress, ecological footprint, or sustainability tied to population, you are looking at Neo-Malthusian reasoning, not classical Malthus. Carrying capacity is the maximum population an environment can sustain without degrading its resource base. Classical Malthus measured it in food alone, but Neo-Malthusians treat it like a dashboard of gauges. You might have plenty of grain while your freshwater gauge is deep in the red. The key exam move is to name the binding resource, which is the limit that runs out first in whatever scenario the College Board hands you. The Aral Sea is the example graders love most because it shows the theory playing out in real life. Decades of irrigation diverted the rivers that fed it to grow cotton for a growing population. The sea shrank into a desert, fishing fleets were stranded on dry sand, and salt storms wrecked public health for miles around. Population pressure plus consumption pushed one resource system past its limit, and recovery took generations. You can see the same pressure concentrated in the world's megacities. Dhaka, Lagos, and Mexico City pack tens of millions of people into spaces never designed for them, and every one of those people needs water, energy, and waste removal. Local carrying capacity gets stress-tested at extreme density, which is exactly why Neo-Malthusians point to rapid urban growth as a flashpoint for resource strain. Here is the insight that separates a strong answer from a weak one. Impact equals population times affluence times technology, a formula called IPAT. A wealthy country with slow population growth can damage the planet as much as a poor country growing fast, because each wealthy person consumes so much more. The United States grows slower than Nigeria, yet its per-person energy and meat consumption create a far larger ecological footprint. Always ask whether the scenario is about headcount or consumption before you label it. Brazil's rainforest shows consumption pressure crossing borders. Global demand for beef and soy, combined with local settlement, clears forest that stored carbon and sheltered countless species. This is Neo-Malthusian stress on three systems at once: land, biodiversity, and climate. And it proves the pressure is rarely about local birth rates alone. Trade and distant appetites drive the loss. A top answer always shows both sides. Critics point out that the alarming predictions of the 1960s and 70s, like Paul Ehrlich's forecast of mass famine, did not arrive on schedule because the Green Revolution expanded food supply. They argue that hunger is often about distribution and conflict, not raw headcount, and that blaming population can unfairly target poorer nations. Neo-Malthusians answer that timing was wrong, but long-run stress on climate, water, and biodiversity is real. On the FRQ, apply the theory, then close with one honest limitation.
You can drill 20 flashcards and 15 AP-style questions on Neo-Malthusian theory in under 15 minutes using the link below. That is the difference between a 3 and a 5. Subscribe for new AP videos every week.